Welcome to 24 Hours of PASS Summit Preview. We're excited you could join us today for Allan Hirt's session on availability groups versus failover cluster instances. This 24 Hours of PASS event consists of 24 consecutive live webcasts. To access any on-demand sessions, please refer to 24hoursofpass.com. My name is Howard Diesel. I live in South Africa and I currently spend most of my time as a production DBA for several clients and love the challenge of taking them from ancient to current without breaking them. I have a few quick introduction slides before I hand over the reins to Allan. He will speak for 40 to 45 minutes and then we'll move on to a Q&A where you can ask any questions you may have. If you go to the technical assistance slide. If you're having any issues, type your issues in the question pane and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The question pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. If you go to the sponsor, I'd like to thank the sponsors now. I'd like to take a moment to thank our event partners. The staging of 24 Hours of PASS would not be possible without their support and dedication. They are the reason for that this event is available free of charge. Thank you to our presenting sponsors, Microsoft and Dell Software. Next slide. Next, as you all may know, this 24 Hours of PASS is a preview of PASS Summit 2014, the largest conference of SQL Server and BI professionals. With over 5,000 attendees representing 2,000 companies from 52 countries, Summit is a time to share, connect, and learn with your peers and industry partners. PASS Summit is not only a week of intensive learning and knowledge sharing that will offer strategic insights, it's a time to network and rub shoulders with industry experts. Taking place in Seattle from November 4 to 7, PASS Summit will feature over 190 world-class sessions across 5 top tracks. These 24 Hours of PASS sessions provide a mere glimpse of what you can expect from the PASS Summit. Find more out at passsummit.com. And if you register by September 26 using discount code 24HOP14, you'll get $200 off the registration fee. The next slide. And now, please allow me to present the speaker of the hour, Allan Hirt. Allan is a cluster MVP and SQL HA co-founder, consultant, author, speaker, trainer of SQL Server, and currently writing mission-critical SQL Server. To you, Allan.
Thanks, Howard. Well, good morning, good afternoon, or good evening, depending where in the world you are. Could be actually probably late, very late evening. My name is Allan Hirt, and for roughly the next 45 minutes or so, I'm going to talk to you about the differences between availability groups and clustered instances of SQL. One of the reasons I do this talk, and I do it every now and then, is because when we think of the word cluster, we generally think clustered instances of SQL, but availability groups also use clusters. So between the fact that both of them fall under sort of the same umbrella of availability within SQL, and both of them use similar technologies underneath the covers, it's really important for everyone to understand the differences between them and some of the pros and cons. As an aside, I will also be doing a pre-conference session at Summit this fall on availability groups that will actually have labs. So if you're interested in availability groups, you'll actually get hands-on experience. The labs are using real VMs, and you would need to bring your own device, like a laptop, something like that. But it'll be a very cool experience. So if you want to know more about availability groups, come to my pre-con. Okay, So at a base level, what are we talking about here when it comes to availability groups and FCIs? So just to level set also on some terminology, when I say FCI, I mean that clustered instance of SQL. And I'm going to, for those of you that don't know what a clustered instance of SQL is, I'll be demonstrating all this in just a couple of minutes. This session will be largely demo heavy. As I already mentioned, both of these features, availability groups and FCIs, are geared towards making your SQL Server more available. How they do that is very, very different. One thing that I need to get out of the way also up front here is that people think that the availability groups or AG feature is called always on. The official name is always on availability groups or just availability groups. It's not always on. There was a time for a very, very brief period it was actually called always on, but by the end of the release of SQL Server 2012, or by the time I should say it RTM'd, it was renamed to be purely availability groups, and always on is a marketing umbrella that covers the availability features both of FCI and AG. So one thing I would just request of everyone in the future, if you're going to be talking about availability groups, use AGs or use a full word always on AGs, because always on doesn't necessarily mean AGs. One of the nice things about both of them is that depending on how you configure them, and it's more AGs in this aspect, they can abstract what goes on behind the scenes. So let's say you have to switch from server A to server B because of a failover. Well, with both an FCI and an availability group, they both have components to them that allow the name of what apps or users directly connect to stay the same. That's a really important thing, because prior really to AGs as well as, but it's always been in FCIs, if you're using things like log shipping or database mirroring, replication, any of the other features in SQL Server that could help you increase availability, you pretty much had to account for that server name switch, which, as we know, especially with some, say, third-party applications, that could be a real pain. As I already mentioned, but as you're going to see as I go through the demos, both AGs and FCIs use an underlying Windows Server Failover cluster, or WSFC. That means that you have to have Active Directory in your environment. You cannot deploy FCIs or AGs without Active Directory. So, and I'm going to touch on that a little bit, but that kind of stuff I'm going to save largely for my pre-com, because in 45 minutes it's hard to go through everything at a very deep level. So at a high level, what are the differences we're talking about between FCIs and AGs? So first of all, if you want to configure an FCI, you have to make that decision before you even install SQL Server. You cannot convert a standalone instance into a clustered instance. For those of you that might have some familiarity with SQL Server, years ago, I think the last version might have been 2005. I know it was in 2000. But there was that ability, but you had to set it up very right ahead of time. So bottom line is it was difficult. As of 2008 and later, for sure, you can't convert a standalone into an FCI. So if you're going to want to cluster your instance and you're 6 months into production, basically you got to tear things down and redo it. AGs are done after setup. So you can install your SQL Server, and then you can decide at some point later to configure AGs. One of the major differences between the two is the fact that they protect different things. So an FCI is what we call instance level protection. Everything inside that instance in the failover will go to the other server, or in this case of a cluster, we call the other server's nodes. So any server participating in a Windows Server failover cluster is a node. And when you have that failover, everything in the instance goes over. Jobs, logins, linked servers, you name it. It's basically your instance stopping on one node and starting on another, and I'll demonstrate that for you. An availability group, however, provides you database level protection. So anything inside the database would be on the other nodes. because you have to restore it over there. So not only do you have two copies of the data in this case, whereas you have one with an FCI, sure, you've got your restore procedures, you've got your data, you've got your schema, but anything sitting outside that database, such as jobs, link servers, instance level logins, I should say, all that stuff you have to manually synchronize on your own. SQL Server does not take care of that for you. With clustered instances of SQL, depending on how you configure it, there is some sort of shared, and I use that term a bit loosely, storage requirement. That means that whether you're using a file share, which I won't be demonstrating today, or you're using something like disks presented to the host, it needs some sort of common storage for the clustered instances. An availability group can just use a local storage to a node. Now, when I say here in this chart can be used for reporting, and an AG is yes, and there's an asterisk next to an FCI, you can connect to a clustered instance of SQL and report off of it. However, the instance of SQL only runs on a single node, so there's, again, like I mentioned, a single copy of the data. Whereas with an AG, one of the replicas, which is a secondary, can be configured to have read-only access. So you can use a secondary for reporting. That's one of its biggest benefits, and also a very big difference between some of the other availability features that have historically come through SQL Server. When it comes to data loss, this is a thing when I'm working with my customers to put an availability strategy in that they all need to understand of what features do and do not give them. With a clustered instance of SQL, because it is going through a stop and a start, you're going to be consistent to the point of failure. So if you fail on node A and you start on node B, it goes through the recovery process just as if you had powered down your server and powered it on. So in that case, if you have incomplete transactions, anything like that, you're going to then have things rolled back or rolled forward as the case may be. With an availability group, however, the difference there is that you can do synchronous or asynchronous, and synchronous you won't have data loss, but if you have poor networking, then you could get backed up. So you really won't be synchronous because then you would have delays to your application because it's waiting essentially for the ACK back for getting hardened in a secondary replica. So you have to sort of take these things into account. So you won't have any necessary data loss, but if you're setting it synchronous. Now, here's the other thing about synchronous versus asynchronous. People I see always getting a tizzy about asynchronous could mean data loss. That's true. However, really what asynchronous is once the AG sends the transaction over, it doesn't wait for the ACK back that it's been hardened in the log on the other side. So assuming you have good networking and things get retried, you probably won't have any data loss, and asynchronous could potentially be as fast or as close to as fast as synchronous in many cases. You just won't get that essentially two-phase commit, and there are some other things that you don't get like automatic failover, but it's also more tolerant of, shall we say, networks that are not optimal. You can configure a clustered instance of SQL if you have standard or enterprise edition. You are limited to a 2-node configuration in standard, but it's possible. As of SQL Server 2014, meaning both SQL Server 2012 and 2014, availability groups is only a feature of enterprise edition. I don't have any information if that's going to change in the future. My hope is that Microsoft does that, but as of now, if you aren't going to be running Enterprise Edition, you can't be using availability groups. Finally, you can have, in terms of the numbers of, shall we say, how you can make this more available, you can have up to 64 nodes in a Windows Server failover cluster, and you can have a SQL Server configuration with FCIs that supports that. An AG obviously would support similar in that sense because it does use an underlying Windows Server failover cluster, but in terms of the feature itself, you can have up to 4 secondary replicas which is a total of 5 replicas, and up to a total of 9 replicas, meaning 8 secondaries in 2014. So now I'll talk a little bit about when I do the demoing in a minute here about where the replicas come in and how that all plays in. But let me give you a little tip here. Personally, once you scale much beyond 6 or 8 nodes, and even 8 nodes could be a handful, manageability becomes a real issue in these things, especially when it comes to things like patching. So as you start to think about availability groups or FCIs in your environment, you need to really also think about not just the availability it brings and how you're going to make things, architect them in your environment, but the manageability story, because you've got to deal with this thing in and day out. Okay, I've done enough talking on some of the ground level. Let's actually look at these things, because this for me is where the rubber meets the road. Normally, in a lot of cases, I might have, say, a Visio diagram or something like that, but in this case, I won't. Now, right now on my laptop, I'm actually running VMware Workstation. Just to show you this is really all live. I'm running all of these VMs, and I'm using nearly all of the memory on my laptop. So I've basically got 3 scenarios to show you. The first is what most of you might be familiar with, but not all of you are, and that would be the clustered instance of SQL, or FCI. FCIs have been around since actually SQL Server 6.5. So it's a well-proven product. It's sort of a love or hate thing with some people, mainly because of the experience they've had in the past with it. I can tell you that SQL 7 and 6.5 and that sort were particularly difficult. But as things got on and Windows improved, SQL improved its installer, things have gotten easier to cluster an instance of SQL. Now, is it sort of what I would call brain dead stupid at this point? No. There's still a lot of planning that needs to happen, but at the end of the day, it's a lot easier than it used to be. So what is a clustered instance of SQL? Very simply, it's an instance that you install, like I said, at setup time, and that ostensibly you really don't care what node it's running on, because the whole point of a clustered instance is to provide protection if you have things like a node failure, a network card failure, underlying Windows failover cluster infrastructure and mechanisms that it brings to the table. So here I've got a Windows failover cluster named Sony, and I've got 2 nodes in it, Vio and Walkman. Okay. Now, if I look at my nodes, now the one that we're looking at this on is Walkman. So here's just a concept that I need to establish right up front that comes in with clustering. Regardless of the total number of nodes that you have, once you install things into a cluster, in this case, or you create the cluster itself, the Windows failover cluster has a different name than either of the underlying nodes. So in this case, my Windows cluster is Sony, my nodes are Vio and Walkman. And in the case of an FCI, you even have something different. So here you see I just clicked on this thing called roles. Now in terms of a cluster, a role is the functionality that you would install. So in this case it would be an FCI. In the past, some of you might be familiar with the term resource group. Well, resource group is the same as a role. And so if we click on this, you'll see here, hey, it's running. You see it's called mini disk, and I'm going to explain this, and the client asset's name is mini. We're going to see how that plays in here in a second. Now, it's got all these resources in it. I'm going to move this up so you can see. Just expand that out. So this is a traditional FCI. I've got a network name resource, I've got an IP address, I've got a disk, I've got the SQL Server resource, and I've also got SQL Server agent. Now, you can technically cluster analysis services. However, it has not been architected to use the clustering APIs. It's basically what we call a generic service. So what that means is that a lot of the special features that come in with clustering, the heart beating, the health checks, are not done because analysis services wasn't coded that way. But yes, you can cluster analysis services. I find that most people don't. There are other ways of making AS available. So most people tend to leave clustering the instance just to the relational engine. This is a simple setup, and by simple setup I mean it's single subnet, single data center, if you will, type of setup. You can also have geographically dispersed clusters that span data centers that are more complex. I don't have one of those booted, but that's another thing that could come into play here, because you could potentially use this for disaster recovery. However, it's a bit more of a challenging setup because other things have to come to play, like mirroring of your storage. So one thing I also want to point out, for example, here is that each of the nodes has an IP address. The cluster itself, here where you can see it in this cluster core resources, has an IP address, and the SQL instance has its own IP address. So there are all these objects and things that get created as part of clustering something that you need to account for when you're having a clustered instance of SQL. So here I've got, as you see, this name of mini, but I've got mini disk here. Now this is just a friendly name for the role. I could rename this if I wanted to. This is just a container name. However, from a SQL Server perspective, that's not what I wanted to do. When I connect to this thing, I connect to mini disk. Notice I didn't connect to VIO, Walkman, or Sony. So if I could, for example, just do a select add server name here, and it's mini disk. So let me talk to you about this a little bit. So this first part, where you see here it's just mini, that's what Windows cares about. That's what gets registered in DNS. That's what gets registered in AD. And that's all Windows cares about. The named instance part, the part after the slash, is purely a SQL Server construct. I should say, excuse me. So with this, you know, it's just like, in essence, installing potentially multiple instances on a standalone server. And what do I mean by that? While I only have a single instance here, I could have up to the maximum supported by SQL in a cluster. The tested limit is 25. In theory, you could go beyond that. Now, you are bound also by the same limitations. So you can have a single default instance in a given Windows failover cluster, and everything else could be named instances, or you can configure all named instances. The one thing you have to watch out for, however, is that this part, this network name here, this mini, has to be unique in the domain. What that means is that you can't reuse it again. So that could be problematic for some. So when you're planning an FCI, you have to think about how this is all going to work and how you're going to lay things out in your environment, and come up with a naming convention that works, because it has to scale for every instance that you install. Now, the named instance portion, the part after the slash, has to be unique within a given Windows failover cluster. So on this particular cluster, I could not use disk again, but I could use it in another Windows failover cluster or on a standalone server. So you're not bound there, but again, this is part of the just understanding what FCIs bring to the table. So here, you notice I just issued a query, and what I'm going to do now is I'm going to fail this over. I only have 2 nodes, so I just, in this case, select the best possible node. Now, in theory, this is simulating a failure. This is not in theory. It is simulating a failover, a failure, I should say. And you'll see that things come online in a certain order. These are dependencies. So here, you notice it says, hey, I can't connect to this thing because during the failover, it lost the connection. So basically, because of the way that this is coded, SSMS will essentially, it'll come back and requery. So basically, it made the connection again. SSMS didn't barf on me or give me a really horrible red screen of death or lock up on me. So what happened there? Well, what happened is that in the switchover from it now owned by VIO, it was owned by Walkman, SQL Server went through a stop and a start. That means all of your connections get dropped. And so if your applications have no retry logic, aren't able to process this, then you might have some issues with a failover. This is one of the things when it comes to FCIs that a lot of people don't understand. They think that just because you have the same name that you connect to, it's always going to be, in this case, minidisc, that it magically works and your application, this is completely transparent to your applications. It is not. So if you don't have that cluster-aware application or a way to retry, then things aren't going to reconnect automatically. So you need to know this about your applications and do proper testing against them. But what we have here is, like I said, that instance. So I could again fail it back. Here are all my server objects, for example. I've got SQL Server Agent. I'll expand my jobs. You should just treat this like a normal standalone instance of SQL Server when you're managing most of this. So for example, let me create just a new job. I'll just call it 24 hours pass. Just take a second. Okay, now what I'm going to do is let me just close this, and I will say disconnect from this, and I'll also close this. I will fail this back over, and there we go. Things are starting to come online. Once the name is up, you'll see that SQL Server will start. That's because SQL Server is dependent on the name as well as the disk to come online. Oh, don't want to save that. But now I can go connect to Minidisk, and you'll see that that job is still there. So there's no trickery here. Like I said, this is your instance of SQL. It's just moving around. Now, how are AGs different from this? So first and foremost, one of the things that I want to show you is that you can have purely standalone instances of SQL. So one of the ways that you can tell if an instance is clustered, oh, that's not what I want to show, is if there's a server property that you can query, but I'll show you here. For this FCI, it is clustered set to true. Makes sense. But if I go here, for example, I have 3 instances, Getty, Alex, and Neil. You notice they say is clustered as false. So, like I mentioned earlier, AGs require an underlying Windows Server failover cluster, but do not require that the instances themselves are clustered. So let me just make this a little bigger. Now what I've got going on here, and I want to show you this first inside SQL Server, there's this new folder looking thing in SSMS called Always on High Availability. And really all this is, honestly, is AGs. I kind of personally wish they just called the thing AGs and essentially just moved this folder up. But hey, that's just me. So I've got, oh, mouse going crazy, an availability group here. So if I look at this, so I've got 3 nodes participating in my availability group. I've got Alex, Getty, and Neil. Now let me just move this over a little bit. Alex and Getty are a synchronous pair, and Neil is asynchronous. So again, just to point out the difference, we're talking database level protection here. There's no concept of synchronous or asynchronous with an FCI because the whole instance moves. In this case, you're using SQL Server to move your data to the other replicas. You know, you can call it mirroring, you can call it replication, whatever you want to call that process. But here, you have to tell it, okay, SQL, I want you to do this synchronously or asynchronously. And you can mix, as you can see, synchronous and asynchronous within a single availability group, which is something you couldn't do with database mirroring. But part of that is enabled just by the fact that you can have more than 2 secondary replicas. Now, you have to be careful, though, because if you only have 2, they need to be set to the same thing. And one of the nice things about availability groups, just like in FCI, is that you can have automatic failover. Assuming, now there are some caveats to that, your data needs to be fully synchronized for that to happen. So if you're doing async, that won't happen. And if you're lagging behind in your network, you have things going on that aren't optimal, then you can't have automatic failover. But assuming everything's working right and everything's good, you could have automatic failover. And I have that set up here. Now, you can also, as you see here, have a readable secondary. And into my pre-con, I'm going to go into how this is configured and what all these mean. But as I pointed out earlier, one of the nice things about this is that if you have a secondary replica that you can now use for reporting, it may actually be a better solution than what you may have today because it's your data in near real time. Because that's a problem that everybody's always tried to solve with a reporting servers. How do I get as up-to-date as possible with my production data? Now you have a way to do it. But notice I'm intentionally avoiding showing you any clustering stuff yet. And that's for a good reason. So what I'm going to do now, for example, is I'm just going to fail this over. Since I'm doing synchronous, and it says I'm green lighted here. Now you can do this through T-SQL. You can also do this via PowerShell, but you know, for demo purposes, I'm just doing it here through the GUI, and we're performing a failover. Now again, notice I did not do this at a cluster level. Anytime you do any kind of failover for an AG, should always be within SQL. So now notice that Getty here flipped to the secondary, and if I go look at Alex, he's the primary. Another thing here, for example, that would be, say, different from database mirroring is I've got a dashboard. You can also query DMVs, and we don't have a lot of time in this session to get into that. And there's also X events. There are many ways to get information about your availability groups. And this 3-node architecture is one I see that's very common with customers. They basically want a primary failover pair, and the third one is either reporting or I should say, a DR node or a DR replica. So think of it this way, and it's essentially what I'm going to show you in a second. After this particular configuration, is you have 2 nodes, say, in one data center, 1 node in another data center, and you can set that up. Now, the challenge there is because it uses an underlying Windows Server failover cluster, unlike, say, database mirroring, everything needs to be part of the same domain. Okay, so I've just showed you all of this. And you set all of this up in SQL, which is why I said this is a post-configuration thing. Now, what's some of the secret sauce behind this? So first and foremost, To enable availability groups, you set it on the SQL Server service. And this would be true, this would be true whether or not you are using an FCI in the mix, or in this case, as I showed you, a standalone instance. Now notice it says that it detected that this is part of a Windows Server failover cluster. And if this is grayed out, or the server you're on is not a node of a cluster, you cannot enable this feature. Now, looking at this from a cluster point of view, here I've got a Windows failover cluster called Rush. I've got 3 nodes called Alex, Getty, and Neil. And notice that those were the names of my instances. I had 3 default instances of SQL Server that were standalone on those nodes. So, but from an AG perspective, you see this AG1 thing. Now, if I go back to SSMS, you'll see that it matches this name right here, AG1. And I could have called it whatever. Probably should have named it something more to fit with the theme of this cluster, but it just proves the point that this is where the link starts to come in. So this resource group here called AG1 has a few things in it. Now, one of the things it has in it is you'll see a network name. It says here server name, but it says network name resource called hemispheres and an IP address. This is what we will call the listener. The AG1 thing, this maps to this right here. So regardless of whether or not you have this, and I'm going to explain what this is in a second, you will always have one of these in the cluster for every availability group. Each availability group will get its own role. So if I had another availability group, say AG2, it would have its own role and its own resource named AG2 in here. Now what is this hemispheres thing? So there's this functionality called a listener with an availability group. This functions basically the same, in fact not basically, it basically is the same as your FCI name. So if I go to that, just to show you, go back to this for a second. When I connected to Minidisk, okay, Mini was the name here, and that's, again, what Windows cares about. And I don't connect to Sony, Vio, or Walkman. In the case of an AG, I would hopefully not want to connect to Getty, Alex, or Neil, but some abstraction. That's what the listener provides. So if I go to the properties of the listener, you can create a port just like you do for an instance of SQL. And notice I have the 200.201.202.175. Lo and behold, if I go to Failover Cluster Manager, that's my IP address. And I gave it a name of hemispheres. Now for applications, I could do this. And I'm going to give you a warning in a second. So I can connect to hemispheres, but if I do this, if I do a select AT server name, you'll see that it comes back with Alex. Why is that? Because Alex is currently my primary node. Now, if I was doing the read-only stuff, you may get a different name, but that's, again, something I don't have time to totally cover in this session. But in a normal scenario where you're connecting to the read-write instance, you're always going to get the name of whatever instance is hosting it. So now, one thing, the caveat that I want to tell you about this is that while I connected to hemispheres here in SSMS just to prove the point, this is not how you should do it in a production environment from a management standpoint. You should always manage by the instance, not by the listener name. It keeps things separate, but from an application perspective, the listener matters. Now, I will say this. The listener is technically optional. You do not have to configure a listener for an AG. A listener is specific to a single AG. So this hemispheres listener could not be used with another AG if I had another AG configured. So again, in the planning thing, you need to think about your big picture here. Now, what happens if I've also got a clustered instance of SQL here in the mix? Well, let's find out. So in this case, I've got a clustered instance of SQL called Grand Illusion. So just to show you that, here's my instance. This here, by the way, if you notice the slight difference in Failover Cluster Manager, this is 2008 R2. The other ones I've been showing you have been Windows Server 2012 or Windows Server 2012 R2. So there's just a slight difference in the GUI from a cluster perspective. But anyway, so I've got a clustered instance of SQL, and I've also got an availability group. Now, here, for example, if, let's say, if I go here, so my clustered instance is my primary. If I try and set automatic failover here, it basically pops up a message saying, hey, you've got a clustered instance, you can't have automatic failover. You have to have manual. So just pointing that out, that it knows you're working on a clustered instance of SQL. Now, just from another standpoint, so I'm going to now fail this over to JY. And actually, let me just show you something real quick before I do that. So if I look at the dashboard here, I just want to make sure we're healthy. Yep, it says we're good. So I'm going to do a failover, then I'm going to pop over to Failover Cluster Manager and show you what happens here. Actually, before I do that, let me show you one other thing. So if I do, let's say my instance fails over to the other node. So what you're going to see is once this goes offline, the AG goes to basically a red X. It's offline. So once the instance comes back up after failover, the AG will come back online. This is by design. You notice it's starting to come back. It'll come back online in a second. So these are tied together, and in a clustered configuration where you have an FCI, the AG always lives where the primary instance does. Now that's always true of a standalone as well, but in since we have a failover scenario here for the instance, the AG moves with it. Now you notice here things went to red because things obviously went down, and then we went back to green. So things are good again. Now let's perform a manual failover here. So this is basically one of the last things I'm going to show you from a demo perspective. So I'm going to go to this. Now JY, actually I keep going back to this, but one other thing I want to show you is the fact that JY here is a standalone instance. So I have a clustered instance in say a single data center going to a standalone DR replica for my AG in what's the equivalent of another data center. So now I'm going to perform my failover. Let's connect here. So now on the back end, from a cluster perspective, you'll see that the AG is changing. Okay? Oh, that. Now notice here, for example, I switched IP addresses. The 200.201.202 went off, is now offline, and the 201 is now online. Because the reason for this is because JY, that node, is in a different subnet. Now you'll see here that it's resolving, and part of this is because we switched manually to an asynchronous node. And again, if you attend my pre-con, I'll describe all this in a bit more, and it went now to green. So everything is now being synchronized, but you'll see here this stuff really does just work. This would be essentially the same if you had to switch to another data center. And natively, Windows and clustering and SQL Server know that you can have different subnets and different IP addresses, but in this case, because I have the listener, I can connect to this Roboto thing here. Just like I would, like I showed in the other example where I connected to hemispheres. Now, one thing that I want to point out here is that even though JY is a member of this cluster, Grand Illusion, which is a clustered instance, can only live on Dennis or Tommy. So I have the 6 cluster, which has 3 nodes, but JY could never own that clustered instance of SQL. So like I said, I'm mixing standalone SQL with clustered instance of SQL in the same Windows failover cluster, all participating in an availability group. Okay, so that's basically it from demo land, and I know we've only got about 10 minutes left, and I want to make sure that we get to questions. So let me quickly finish up the slide deck, and we'll open the floor for questions in a moment. So as I've just shown you for basically the past 40 minutes or so, there's quite a few differences that you need to understand, and even some subtleties if you're going to combine FCIs and AGs. Because while they both use a cluster, as I showed you, they're very different in the mechanisms and how they work. You can combine those FCIs and AGs, but I think you could tell there's a lot to it. Especially that last scenario I just showed you where I mixed a, say, FCI in Data Center 1 and a standalone in Data Center 2, joined them by an AG. That's a lot of planning, you know, and you're going to have to understand a lot of things about networking and Windows and AD. You can't just rely on your back-end guys because you'll probably know more about this than them. Again, I want to reiterate that as I showed you in that second setup, you do not have to cluster SQL Server to do AGs. You can actually have standalone instances of SQL participating in an AG. There are some subtle differences that do come in. For example, if the cluster itself was down, the instances may be up if the nodes are up, but anything participating in the AG would be down. I didn't demonstrate that. That's not something that in 40 minutes I would really generally show because it could break my other demos very easily. And just sort of to reiterate, I'm doing a full day pre-con and availability groups where I'm going to expand on all these topics, and you get to build your own. It's sort of a first for PACS, actually. I think it's the first time they run live labs. We should have a good network connection because it will be done on real VMs that you'll have access to, and the VMs are actually going to be hosted. So I look forward to hopefully seeing some of you there. And with that, let me open this up for questions. And I will also be, just so you know, presenting another session at Summit. Don't know what day yet. On Quorum, which is related to actually all this stuff, because that's an important aspect of your Windows Server cluster configuration to make sure that you stay up and running. So again, that code, 24HOP14, to save an additional 200. Thanks for attending, and let's open up the floor to questions.
Great. Allan, the first one that we'd like to talk is from Jameen Patel, and his question is, any quick way to sync logins except restoring the master database in AG?
Sure, so that's a great question. So you generally don't restore master from one instance to another. So I would recommend that you don't do that. The easiest way, and I don't know the KB article off the top of my head, but basically you script them out. Now obviously there could be some security issues around that, so you need to make sure that it's done securely and that where those scripts would be stored. There are ways to do it, I believe, via SSIS as well. But in general, don't restore master. Do a script. If you do a search on support.microsoft.com, it's like SQL synchronizing logins. This has been around forever. They have a script that you can just copy and paste and use.
Thank you. The next question is, can AG provide 24/7 uptime as FCI can take 10 to 16 seconds to fail over?
So that's a loaded question. Now, in theory, the answer is yes. Now, FCIs really do provide that as well, but remember, because if you're using the listener, for example, the listener has to stop and start. So you may see a potential interruption in the stop and start of the listener. If your clients are using the latest .NET stuff, and that's some of the secret sauce here, there are some, say, switches that you can provide in there, especially if you're doing multi-subnet, that it will retry to reconnect. So to the client, from a client perspective, it may handle some of that. Now, a thing that you should be aware of, if you've got an in-flight transaction, it doesn't carry that over. I mean, it's going to essentially get rolled back, kind of like excuse me, an FCI. So, you know, this isn't something like RAC where it's multiple processing. You still have a single instance processing your write transactions, and if it doesn't go through, then it's not getting through to the other side. So I think it depends how you define that, but in theory, both FCIs and AGs come close, but will you incur no impact to the end user? I can't 100% guarantee that.
Great. Next question from Deepa says, in AO AG, can backup be scripted as copy only on secondary with T-log backups to follow, and we can use these for restore purposes?
Good question. So I apologize for not mentioning this, but yes, your secondary replicas can be used to do T-log as well as full backups with copy only. It's one of the nice benefits. Now, so the short answer there is yes. The other question is, do you want to do that? Because, for example, you would have to make sure that, for example, if you're doing differentials on your primary and you wanted to use that, you have to gather all this stuff in one place because your backup history is local to a particular instance. So if you're trying to make sure you have all the latest stuff, you now have to do a little bit of coordination on making sure that the backups get all coordinated in the right place. But like I said, short answer, yes, you can make full and T-log backups on your secondary replica with copy only.
Thank you. Moving on. From Fred, he asks, can we replicate to a DR site on a different VLAN without presenting an IP address for the cluster with AO-AG? And the reason for that is to avoid two IP addresses for the cluster in DNS.
So I showed you the normal multi-subnet failover. You could, if I'm interpreting your question correctly, you could create a VLAN so everything appears as if it's on the same subnet. That is totally possible. So that's like the old way of doing things. So if that's what you mean, like for example, if you gave the listener 200.201.202.3 and you wanted it to stay the same, you could create a stretch VLAN. That's not generally the recommended way because it's more overhead for your networking guys to create that. But if they're okay with it and you want to do it, that's totally supported. But natively, as you saw, Windows failover clustering and by association SQL Server support the multi-subnet failover stuff within Windows failover clustering so that it will flip IP addresses. So it's up to you. Both would be supported. It's just a matter of how much work you want to do.
Great. The next question we talk about is, can SSRS and SSIS be configured for AG?
So the SSIDB, the new functionality they put in SQL 2012 to store your SSIS packages. I almost slipped and said DTS there actually. Your SSI, that dates me right there. Yeah, SSIDB can fully be protected by an AG, so you're good there. Now with SSRS, the interesting thing there is you could protect the main databases that have your data, you read-write data. So in that way you can protect SSRS, but any configuration data, I'm not sure, I've never seen anybody use it that way, and I'm not sure it's supported off the top of my head. So I would have to defer that question right now. But if it's for your main database that has your reporting data, yes. But outside of that, I kind of want to say no, but I don't want to commit because off the top of my head, I'm not 100% sure.
Thanks, Allan. Maybe time for one more question. Can you have two different versions of SQL in your AG? I.e., only one instance of 2012 and one instance of 2014, or do they have to all be consistent?
Okay, that's a loaded question. The short answer is no. You can't mix instance versions. So you can't generally have, for example, 2014 primary going to a 2012 secondary. That's just no. Okay. Now, in an upgrade scenario, you might be in a little bit different state. For example, like if you upgrade your, say, a secondary replica to 2014, and then you're going to upgrade the primary. That's about the only time that you might be in a mixed scenario. But in general, no, you can't mix versions. But by the way, just as the same token, you can't mix versions of Windows in the same cluster either. So I'm sorry that that's the case, but it is what it is.
Thanks, Allan. Thanks very much. I think we should move on. Basically, the guys, there's a session coming up next. It's in-memory OLTP internals. And please stay tuned for the next session with Kayleen. Thank you very much for attending, and thank you, Allan, for your presentation. It was very interesting. Appreciate it.
Thanks, everyone. Have a great day.